What does this kitchen have in common with the house it is built inside? What does the house have in common with the earth it is built on? And what does the earth have in common with the universe that it exists in? All of those things have something in common. They're all made of these guys. This is a very big picture for a very small thing. This is an atom. Atoms have three parts to them. They have electrons, protons, and neutrons. Let's take a look at those three parts in a bit more detail. On the screen now is an electron. Electrons have a charge of negative and a mass of nearly zero. They are the smallest part of an atom, so small they hardly exist at all. They orbit the atom on the outside. We'll have a look at that a bit closer soon. The next particle is a proton. Protons have a charge of positive and a mass of 1. And we call this its relative mass because they're too small to measure. The next particle is a neutron. Neutrons have a charge of neutral, so no charge, and they also have a relative mass of 1, and they exist inside the nucleus of an atom alongside the protons. This is a piece of charcoal, and charcoal is made of carbon. The chemical symbol for carbon is C. When we see the chemical symbol for carbon, we sometimes see some numbers written above it and below it. The top number is its mass number, and the bottom number is its atomic number. But what do these numbers mean? The bottom number is the amount of protons that are inside carbon. We can sometimes call this the proton number. Carbon has 6 protons. The top number, the mass number, is the amount of protons and neutrons inside carbon. There are 6 neutrons and 6 protons. If we take away the proton number from the mass number, we can calculate how many neutrons are inside carbon. Every element has a different proton number, but may have the same mass number. Because sometimes elements have more neutrons than protons, and we call those isotopes. Isotopes are naturally occurring radioactive atoms, and we can perform something called carbon dating from isotopes. When an animal dies, the carbon inside it is trapped. We can work out how old that carbon is and how old the animal is. The isotope responsible for this is carbon-14. Carbon-14 is a naturally occurring isotope. When it's ingested by the animal, either through the air or food, it is stored in the body, ready to be used and given off again. When the animal dies, it's trapped there. Because it's radioactive, scientists can look at how long it's been radioactive for and calculate the age of the carbon-14 inside the animal, and therefore work out the time period of where the animal is from.